Good day to you and welcome. This is Hunting Malware, basic tools for IT analysts to hunt and terminate Windows malware and spyware. Let's talk about what this course is about primarily. It's about identification techniques, being able to identify that which is bad by knowing what is normal on a Windows system, and then being able to baseline your systems and know exactly what's supposed to be running on them, so it makes it easier for you to find something that should not be there. We're going to address common malware and spyware, adware and unwanted software. You may be out in the field and see something. We may ask you to look at something because we're seeing something that is abnormal and we want you to check it out. And also about becoming better at what you already are, which is an extension of the security team because, as we know, security is everyone's responsibility. But really, most importantly, it's about becoming a bigger hit at parties and family gatherings and Christmas time because you'll be able to clean everybody's computer. What this course is not about is about advanced malware. It's not about rootkits. The average piece of malware may cost $100, $200 to make, the average common piece of malware or spyware. Whereas Dooku, in this particular example, was created by governments and cost $50 million to produce. These rootkits will hide themselves. You're probably not going to be able to find them as easily. Advanced attacks don't touch disk much these days, and they often use legitimate internal tools, so you may not be able to see a bad guy on a system and necessarily recognize that all the time. And of course, professional anti-malware analysis does require years of deep training. It's also not a guarantee of finding or catching anything. Just because you don't find something, if the system is acting bizarre, you still want to escalate it. And ultimately, really, when it comes to malware analysis, the only way to be sure is through memory analysis, and that's a far more advanced topic than we'll be covering here. The other thing this course isn't about is about covering every possible rogue process. In other words, there are applications that a lot of you folks have in your departments that many of you probably consider malware. These techniques, however, will see a lot. They will be able to help you see and clean a lot. This is a technical course. There are some assumptions here. If you do not understand these things, this will give you a good place to start in your research, in your learning, to learn these fundamentals that will then help you to build on them. But this course has a basic understanding of these Windows terms and concepts. So the registry, okay, Windows processes, Windows services, the file system, how it works, and rights and permissions, and even the difference between those two. So this is a technical course. I want to give credits to two gentlemen who a lot of this material came from. This is kind of a merger of a couple of their talks with the addition of some other information. I call these guys Jedi Masters. First one is Malware Jake Williams. We don't call him Malware Jake for nothing. This guy is super brilliant. He's with Rendition and Security. He's a SANS instructor. The other guy is Mark Rasinovich, who many of you have heard of before. He's the Chief Technology Officer of Microsoft Azure. He was the creator of Sysinternals, and he still maintains this product. And we're going to delve into the Sysinternals suite extensively today. So definitely, if you're on Twitter, definitely two guys worth following. So before we begin, I want to give you an introduction to the Sysinternal Tool Suite. The Sysinternal Tool Suite, this is one of the tool sets in the Sysinternal Tool Suite. The Sysinternal Tool Suite was created back in 2004, I believe. It was originally called NT Internals, and it grew from there. And it's a suite of tools that now is owned by Microsoft that was created initially as troubleshooting tools for Windows. And there's a whole suite of tools. Way more tools than you can imagine, and most of them we're not going to cover today. But they're definitely tools that you want to look at for troubleshooting. These tools have been made available for free. You can get it from Sysinternals.com. You can either get the full suite or individual tools available. We're going to look at 4 tools today, which are the primary tools that are used for hunting malware. Install the tools you need for a particular case and then remove them afterwards. Or better not yet, just do in Windows, just do start run and put that URL there in the name of the tool. So if it's procexplorer.exe, you just put that tool name there. And it'll actually run the tool from the live Sysinternals website. So you always know you're getting a fresh, clean, malware-free copy. The other thing you can do is map a drive to livesysinternals.com so you have access to the latest tools. Because Mark's always updating these tools, and I find that when I keep them up to date, say for example on a fob, and then 3 months down the line, he's released two later versions, and so I have to update it and download on that. This is way easier. You always know that you have the freshest version as well as clean versions of the tools. So we'll dig in quite a bit into these tools in a minute. But Sysinternals is way more than security tools. They really are tremendous troubleshooting tools for Windows environments, Windows applications, Windows software that's doing weird stuff, or even just trying to figure out what exactly is happening on a system, what it's talking to on the network. There's a couple of very good blogs. There's some videos and some other things where real-world examples of solving Windows problems at the first URL, and then of course there's a Sysinternals blog as well. And again, you can find out stuff on Twitter as well if you follow Mark. But really, the full suite, when you dig into it, it has a lot more tools that are useful for troubleshooting Windows. We want to find the counterfeit. We want to find the malware. We want to find something that's not supposed to be there. And the way we're going to approach this today is we're going to focus on what's normal in a Windows environment. Now you're going to see a lot more on your systems because this is a bare-bone Windows 10 system I'm working on. You're going to see a lot more software because you've installed a lot more software. You have more applications. You probably have Office running. But those are things you should expect to see. And so this will help you understand some of the other things that come in Windows that you may or may not have a full understanding about. So let's focus in on what is normal within a Windows environment. There are a couple things that you do need to know. First thing is process names. Okay, we want to know what the names of the processes are that normally start in Windows. We want to know what their parent-child relationships are. In other words, a lot of times when a process will start, it will give birth to a child. And then that child process will start maybe its own children that will run. Sometimes a parent process gives birth to a child and then dies. Then that child becomes an orphan. We want to focus on knowing normal process paths. In other words, if a process is running, what's the path in the file system where it's supposed to be running from? And then finally, what the normal command line arguments for that particular process. What we want to know, in addition to needing to know, is expected DLLs, and we'll talk about DLLs in a second, and what the paths are for them. There's a concept called DLL hijacking, where you put a DLL in place so that when an application runs, it runs your DLL instead of its own. It's a great way to hijack an application and use it to escalate privileges on a Windows system. Well, if you're looking at a Windows system and you see calc.exe, which is what? Calculator. If you see it running a network DLL, is that a good thing? It has no reason to be able to need to talk to the network. So you know that's probably not really calc.exe that's running there. Well, you want to know which user started the process. When should the processes start relative to boot? Is a process that's supposed to start at boot time close to the boot time, or do you see a copy of it that's running within the last few minutes? That doesn't look right. And of course, you want to know what services usually start at boot time. Let's talk briefly about DLLs. DLLs are small programs that live on disk, which can be called by a larger program that's running on the computer. Okay, what they do is various other things that are normally done on the Windows system to allow the programmer to build just the core elements of the program and not have to reinvent the wheel every time. So if you're building a program and you want it to talk to the network, why rewrite the network stack every time? You don't have to. Windows has the DLLs for that. And so they're pieces of code that run. They don't have to be compiled in the main program, so the programs can be smaller. They can use the other pieces of the code, and then they're dynamically linked to the program. So let's start with the Windows boot process and look at the opening bands. Before we do that, I want to show you real briefly here a little bit more about this particular program called Process Explorer. And I'm going to zoom in here so it's easier to see. This is the first and probably the most important tool that I'm going to show you today, Process Explorer from Sysinternals. Because what this does is it allows you to explore all the processes that are running on a Windows system. So anything that's running, any piece of software that's running in RAM and memory is going to show up on this list. And in this particular list, you can see there's actually a column for the processes here. There's a column for the amount of CPU that they're using. This is memory information. This is their process ID, their description, company name, and I'll show you some of these other fields in just a second here. Now, one of the cool things about this particular program is it gives you a lot of information, but it also gives you the ability to see the process relationships. So over here, we see that this particular process here has given birth to this process right here and this one. Then there's another process here that's kind of sitting off by itself, so it looks like an orphan. Then you have this process here that also looks like an orphan, but all these other processes that are children of this particular process. And all we have to do is collapse that process, and we can collapse everything that's in that view so we can just see everything else except that particular process's children. A couple of things that are very interesting about Windows, and I'll just ask this question right off the top of the bat. First, can anybody tell me what the Windows shell is? What is the Windows shell? Explorer.exe. When you log into Windows, the shell that is presented to you is called Explorer.exe. Now, Microsoft uses that term variably, so when you open up Explorer to look through files, they use the same term. You open up Internet Explorer to explore the Internet. But Explorer.exe is your shell. So when you log into a Windows system, that process right there, Explorer.exe, is yours. And then everything underneath here is from you. Okay, now one of the cool things about this tool is you can hover right over it. You can see what the command line is for the tool. This is actually the Cisco VPN client. And you can see the full command line and the path of it. And again, it's a child of Explorer.exe. Now there's colors within this particular program, and I'll get into the details of some of these colors in a minute. But the cool thing about this particular program is that you can go into properties of any one of these processes, and you can see details like the path of the process, what its command line is, its current directory, who its parent is. In this case, it's non-existent. This one here is on the far left. It's an orphan. You can see things like, is this thing talking on the network or is it listening on the network? And you can also see things like strings, and we'll get into this a little bit more. And I'm going to show you, towards the end of this, you're actually going to watch some video by Mark Rusanovich demonstrating how to use these tools to clean up certain malware. And when you do, he'll show you how to use the strings option. So now that you have a little bit of background so you know kind of what you're looking at, let's go ahead and get back to the Windows boot process. These are the opening band. Without getting into the details of the hardware process, when the hardware boots and the disk is accessed, first thing it does, hands it over to the NT loader, which is the NT bootloader. It's been around forever. And then that hands it off to the Windows kernel. Kernel.exe is the kernel. In Process Explorer, that particular process is known as system, and it always has a process ID of 4. So here it is here. Good old system. And you'll see it has a process ID of 4 here. There's also this little thing called interrupts, but more importantly, there's this thing called smss.exe. And system immediately spawns sms.exe. Now, smss.exe is the parent of all Windows processes. So if anybody asks you at a party, what's the parent of all Windows processes? What's the thing that if you were to kill this process in Windows, it would blue screen and it would die? It's smss.exe. Now, there's always one that's spawned at boot, and then a new one that's created that gives birth to that winInit we saw, and then exits. And every time you log in, it'll birth one, run whatever process is needed, and exit. So there's always one running. It's called the session manager. It's always owned by system account. Now, can anybody tell me what the system account is in Windows? Anybody? The system account is the most powerful account in the Windows environment. It is more powerful than administrator. It is more powerful than any other account. If I, as a bad guy, own the system account or own a process that is running a system, I own that PC through. So NT authority system is something you will see a lot in this process tree. And that's a good thing, because a lot of these processes, people think, oh, there's sms.exe, and it's running as administrator. We'll see in a minute that that's not a good thing. That's actually a bad thing. So its path is going to be system root system32. Now, what do I mean by system root? In various versions of Windows, the system root differed. Okay, it went from C/WinNT, C/Windows. So the variable system root is what's used generally. But that's generally, in modern versions, it's C/Windows/system32. So remember that, because you want to expect stuff to run out of system32. It never has any arguments, and again, this is all in your handout, so you can use it for future reference. Windows will never kill the process. You can actually try to kill it in Windows 7, it'll ask you, are you sure? And it does make a great name for malware, because people expect to see this particular piece of software. And in doing so, no matter where they see it in the process stack, they may not understand the relationships or who's supposed to be running it. So it makes a good name for malware. So smss.exe, sitting right over here, the Windows Session Manager. Next one is csrss.exe. And you can see csrsx.exe right here. That smss.exe that was spawned and died gave birth to WinNet as well as csrss.exe. And this is basically a process that's responsible for the console handling, the GUI shutdown, that sort of a thing. It's part of the client-server runtime system. There was only one copy before Windows Vista, 2 copies now in Windows Vista and above. Path is system root 32, always owned by system account again. And that's a process that you will see at the beginning of the process stack. Then there's WinInit.exe, and WinInit's the one here that is the parent of a lot of different processes. WinInit is the launcher of the majority of background applications that are always running in the Windows environment. So you will see WinInit and then you'll see a ton of stuff running. It's always owned by system. It always has a low process ID. What I mean by that is that if you try to run something that you disguise as WinInit on a system, generally it's going to run with a higher process ID. So you would expect to see this in a low process ID. Path is always system 32. Again, there's a consistency in the path you see here in a lot of these system processes. It never have any arguments, and you'll never see more than one copy of it. If you see 2 copies of WinInit on a system, you know you have a problem. WinInit then spawns this thing called services.exe. And here's services.exe right here. And services.exe is really important because it's responsible for launching all the services that run in a Windows environment that are expected to run, all the scheduled tasks, loading of devices, device drivers. It's always owned again by, see the consistency here. It's always owned by one NT Authority system. Path is always system 32. It does not have any arguments, and you'll only see one copy. And then what services.exe does is goes crazy and gives birth to a ton of children. And those children are called svchost.exe or servicehost.exe. And this is basically a generic process that runs in Windows that's responsible for hosting Windows services or Windows Service DLLs. That's its job. It generally is run during boot time. The parent is always services.exe, and I'm going to show you some tools and tricks that you can use to make sure all the parent-child relationships are all cool. So services.exe gives host to service host, and it gives birth to a lot of them depending upon how many services need to run in Windows. Now, system32 is the directory again, and it always has this -k service group as an argument. And that -k service group is an important thing because if you see a service host that's running without that argument, you know you probably have a problem. So this is really heavily used by malware developers to hide in plain sight because there's so many service hosts running on a system that people don't even bother to look to see if, is that a legitimate service host running? Is it have a parent of service.exe? Does it have K as a argument? So let me just quickly here show you. You can see these service hosts here. You can see a number of them here, and if you hover over the top of them, you can see what particular services they run. In this case, the Time Broker, SSDP Discovery, DHCP Client, TCP/IP NetBIOS Helper, various other services you can see if you hover over the top of these things. So the service host basically hosts those services for Windows, and then they have children oftentimes underneath them depending upon what particular service that they're trying to do. So a lot of service hosts here. How do you know that all these service hosts that exist on this system have a particular legitimate purpose? There's a couple of tools that you can use to find rogue service host processes. And this is a good things for your toolkit. It's on your slide, so you can throw them in your toolkit as a batch file if you just want to run this batch file on systems that you're looking at to be able to verify a number of things. You should never see these things running from the temp directory, okay? And that's a great place for attackers to run stuff from. I mean, temp is just a great place to do that, no matter what the OS is. But you should always see these things from legitimate locations. So an operating system obviously can lie to you if it's a rootkit involved and hide completely, or tell you, oh yeah, everything's fine when it's not. But for the most part, there are some particular tools that you can use, and I'm going to show you all these scripts in just a second here. The other thing you want to look for is misnamed service hosts. Creating something that's svhost instead of svc, that's a common tactic. It's been done a lot. So the first thing, let's go ahead and verify the running path of all these service host processes here. And I'm going to remove the magnifier for a second here and take this first string that we see on that first slide and run it in a command prompt. And what I'm doing here is I'm doing a process list, and then I'm finding service host. Okay, I'm looking at the executable path. So here we can see that everything that runs service host is actually coming from the Windows System 32 directory. That's a very cool thing. The next thing that we want to do is we want to look at the task list and find what the process ID of services is. Services.exe, which is the parent. And in this case, we can see that the process ID is 784. Okay, so we know that that mother of all these service hosts should be 784, right? This is, I mean, you can do this in Process Explorer, but it's a little more tedious. But if you put these things in a batch file, then it really makes it simple. The next thing we're going to do is we're going to get the parent process ID and the command line for each one of those particular service hosts. Notice, services has a process ID of 784. This string, which looks for all the service hosts, get the parent process ID, they all have 784. That means that all the service hosts on this system have a legitimate parent process. They're not rogue. Very good thing. The other thing here is you can see the command lines for all the service hosts. And notice about the command line, they all have that -k argument for the services that they're running. Very important that you see that -k. If you don't see that -k, you know you have an issue. These are some rules for finding rogue service hosts. You should never see them run by an administrator. And there are some other things you can do here, like task list to find string service hosts, to look at see what processes are actually hosting services, and you can do that one on your own. But you'll start to recognize these as you practice. Also, as you spend more time in a tool like Process Explorer, you'll begin to get used to what you're seeing, especially on your systems, because your systems are going to be different than maybe the person sitting next to you. The reality is you get to know what's supposed to be running on your system, so it's normal, and look at them from this perspective. It's more easy to spot what's not normal. But these are some of the tools and techniques that you can use to take a look at some of these processes and see whether they're legit or not. Let's talk about rundll32.exe, and that's the last process we're going to focus on. Then we're going to dig into the tools. This particular program exists to run DLL files. So, matter of fact, here, if I go back to this Windows system, and I do a Command R, and I'm going to run the time date control panel. I run the time date control panel here, and it's running as me. Here it is here. And if I look at Process Explorer, and I go down here to the bottom, you will actually, oh, I need to unfreeze it. I had frozen it. When you normally launch Process Explorer, you can see it's doing live updates. If you hit the space bar, it pauses that. I had paused it before because I didn't want it running in CPU in the background. But now that it's running here, we can actually see a process called run32.dll.exe. It's running under explorer.exe, so it's my process, and it's running the time date control panel. And one of the cool things about this particular piece of software is if you have something that's running, and let's say you go down here and you go, what is this particular process? Where is it in the stack? So if I put my cursor up here, I can use this little thing here, find the Windows process by dragging over it. When I drag over it, it moves my cursor down to the bottom and says that's the process that you just drove over the window. So you can identify which process in this stack is related to which window. Run32.dll.exe is running this particular time, date, and control panel. But bad guys use this. They'll use this particular executable to run a DLL to communicate to the internet. Malware latch onto it, and it is a common executable. If you hover over a run32.dll, you'll actually see where the DLL exists. If you see a DLL that's running out of somebody's user directory or temp directory, someplace other than System 32 or a legitimate system location, you should be very suspicious about a process like that, because those kind of processes you know are not normal. Now, some software developers do some weird stuff, especially older software that you may have around. So you want to look at that and check that out as to how that works on your system. But the bottom line is that rundll32.exe is used for that, and you'll be able to see by just hovering over the process where the actual DLL is running. So let's get down to hunting then. What are we hunting? We're looking for processes that don't have an icon, that have no description or company name. We're looking for something that claims to be from Microsoft but it's not signed by them. What I mean by signed is when software vendors release software, generally the ones that are legitimate will sign it with their private key. and then you can use this tool to verify who the signer is. So we're looking for unsigned images. We're looking for stuff that's running out of the Windows directory instead of Windows System 32, as well as out of the user profile. You're looking for software that's packed. I'm going to show you an example because this Windows system here actually has a piece of malware running on it that I put together for the purpose of this demonstration. This particular piece of malware is packed software. Now, what do I mean by packed? One of the things that you're always trying to do in lab situations and when you're testing environments is try to get past antivirus, right, with your software. And if antivirus knows the tools that you're using or the software code, it's going to flag it and not let it through. So in order to get it past antivirus in this system, I had to pack and manipulate the code in this software so that it was unrecognizable to antivirus. So we're looking for things that encode strange URLs in their strings, and Mark's going to show you that in just a second. You're looking things that are listening on the network. This is huge, folks. Know which processor is supposed to be listening on the network for connections from other computers, because those processors are supposed to be legit. And if you see a process that's all of a sudden listening on the computer that doesn't look right, you know you have a problem. Because again, you're learning what's normal and then being able to easily identify or more easily identify what's not normal. And then finally, anything that hosts a suspicious DLL or a service. So let's talk about some guidelines for dealing with some bad stuff. Here in the county, and these tools and techniques are for your use, wherever you go, whatever you're doing, at home, at work. For serious infections, generally here at the county, we want to reimage the box anyway. Why? Because it's fast now, it's easy to do, it's the safest way to go. It doesn't mean we don't want to investigate to see how the system got infected, but what we want to do is reimage those boxes. Many of you, as IT analysts, department IT staff, are asked by us to be first responders, to go and determine if an infection is in place. If it is a county system and you do see something wrong, definitely interact with security. Let us know. We can give you some guidance as to where to move from there. One of the things that we do recommend is disconnecting it from the network and determining its scope to make sure something's not going to spread. And if it's something that's common or something that's not really a threat to be, across the network, or it's not crypto wall, it's going to start eating your network files alive, then you can plug it back in and use some of the tool techniques I'm going to show you here in a second within Process Explorer to validate that system. And if you're not comfortable with something, always back away. Somebody went to the class this last Thursday and actually responded to one of their users, I think it was yesterday, and saw something bad on the system, ran Process Explorer and went, hey, and called me to tell me about it. It's like, this really is cool. But then they said, you know what, I wasn't comfortable going any further, so I called IT. And IT just worked at it from there. So basically put, don't be afraid or ashamed to back away if you're not comfortable. And always report the results if it is a county system to the information security team. So Mark has some malware cleaning steps that he'll mention in his video, but his basically to disconnect from the network, identify the malicious process, terminate those identified processes, identify and delete the malware auto starts. I'm going to show you how to do that. Because when a process is running, it has to start somewhere, right? And Windows has to configure it to automatically start on boot if it needs to stay there regularly. So you'll be able to learn where those are at. Then delete the malware files and rinse repeat, because it really is a rinse repeat situation. So let's go ahead and dig into Process Explorer here. A couple of really cool tools that are available to you in Process Explorer right out of the box is the ability to go up here to Options and to verify image signatures. And you'll see that it's populating this particular column over here. And it's actually showing that the software that's running is either verified, has a signature, who the signer is, and of course stuff that does not. So you see here, this is all Microsoft stuff. It's verified. There's some stuff from VMware running. Cortado AG. There's no signature in the subject there, but this is the VGAUth service. I'll show you another way to verify that in a minute. And you'll see there's all kinds of stuff here. Cisco Systems, there's again Microsoft Windows. And then there's this purple one here that doesn't have any signature at all in it and looks funny. So that's really cool because it immediately allows you to see, okay, this is something that's been signed by a vendor and it's been compared with their public keys, and yes, it's a legitimate piece of software. So that's pretty cool. You can turn that on right away. You can leave that on. but I left it off at first because I wanted to show you how to turn it on. The other tool that's extremely useful is VirusTotal. Now, we talked about VirusTotal in the last couple of awareness presentations. VirusTotal is a service that is now owned by Google. It allows you to be able to submit software, binaries, files, whatever, and have it scanned against about 55 different anti-malware engines to see if anybody recognizes anything bad in it. Known software is almost always, that was a little snitch by the way in case you want to know, check it out. Known software has already been checked out, so it doesn't have to reanalyze known software all the time. It also has the ability to submit URLs, that sort of thing, various stuff. The neat thing about VirusTotal, it has this great API that's used by a lot of different software to determine whether software is bad or not. So we can go here on options, virustotal.com, and check virustotal.com. And when we do that, it will submit the hashes to VirusTotal, in which case, little snitch just letting me know, hey, your VM wants to talk to VirusTotal. I'm saying that's fine. Always watch your outbound traffic, folks. And look, it actually populates this particular field here. And it will show you if VirusTotal has found any problem with any one of those files. Very handy because it does it all for you at once. And then if you want to look at a particular file here, you can actually just click on the URL. It'll launch Internet Explorer, which I'm going to allow just to go to 80 for now, and 443 for simplicity, and no. And it gives me a report on that file. It tells me that svchost.exe, there's the hash, it's legitimate software. 0 out of 54 engines found a problem with it. So you can go right away to that particular link and look at a particular piece of software. So a lot of times known malware, okay, like garbageware, and you'll see this in Mark's video, will actually show like, I don't know, 10 out of 54 or whatever, or 30 out of 54, and it's pretty obvious. But bottom line is, it's really cool to be able to have these two tools because you can immediately see what's going on in the environment. So here we are on a Windows system. Everything looks good from VirusTotal and Microsoft except for this bad boy that is running packed. And look, it's running out of the Windows directory. This is weird. What's this puppy about? Well, there's a couple of other tools that are very useful, and one of my absolute favorites is this one as part of the Sysinternals utilities. It's called TCP View. The cool thing about TCP View is it actually shows you what's going on your system from a network perspective. What's running, here's the processes over here. Here's the protocol that is being used. Here's the local port that it's and the remote port that's connecting to. Here's what it's using, HTTP, HTTPS, and here's its status. In this case, time wait means that the connection's over and it's waiting for the connection to completely close. And when they finally do close, they turn red. New stuff becomes green. Established connections are just that, established. And then you see these ones called listening. Now here's the very interesting part about that. You always want to know that baseline of what's listening on your system. So here we go and we look around on this particular system. We can actually look for that process within the system, and there it is, WinHost. So it actually lives in you can see it in TCP View because it is actually listening on the network on what port? 4444, that's an interesting port. So in other words, we've already checked out these other processes using Process Explorer. We're looking for WinHost, and we found it here, and sure enough, it's listening on a port. What does that mean? WinHost is a backdoor. It allows me to remotely connect to this computer, get a shell on this computer, and interact with it. If you see something that's listening on a network port that you don't recognize, you definitely want to dig in and investigate it. The other thing, like I said, with TCP View that's really cool is that you can see what's talking and what's going on your system. So a lot of people want to troubleshoot. I'm sending a packet that's supposed to be going out the state network instead of out to the internet. Where's it really going? This tool will show you. It'll show you what the endpoint is trying to connect to. So we've identified WinHost.exe as a PAX executable. VirusTotal doesn't know anything about it. It's not signed, even though it claims to have some Apache code in it, which is part of the tool set that I used. So how do we kill this bad boy? How do we get rid of this particular process on the system? Well, the first thing we want to know is how the process starts. And we're going to do that by using another Sysinternals tool, auto runs. Okay. You'll notice that I'm running auto runs as an administrator on the system. I want to explain something that a lot of people don't understand with regards to the difference between an administrator account, the system account, and a regular user account. In Windows, these are identified as what are called integrity levels. If you're logged into a Windows system as a normal user, your integrity level is low. If you're logged into a system as an account that has administrative privileges, then your integrity is medium. Why is your account medium in that sense rather than high? Why would you think that running an administrator would only be medium? Anybody have an answer to that? No, it actually has to do with whenever you're doing something in Windows like this and you want to do something elevated, what happens? Windows presents you that prompt, the UAC, the access control prompt. That's the jump from medium integrity to high integrity. That jump there is when you become high integrity on the system, and then you basically have full access to that system. So if, say, you're running as an administrator on your system, and I send you an email that has an attachment on it, and it runs, gives me a connection, now I am in your system as you. I'm in your system as you, you're running as administrator, my integrity level is the same as yours, and it is medium. In order for me to steal passwords from your system, I have to bypass that UAC and go to a high level of integrity. And that high level of integrity is what gives me full ownership of your system. And Microsoft built that in to keep malware from being able to have high integrity automatically, even if you're running as an administrator. And that's done on purpose. So the UAC then changes the level, and so that's one of the reasons why I need to run these tools in high integrity in order to see everything that's going on in a Windows system. This particular tool here is called Auto Runs, and the cool thing about this is this will show you everything that starts on a Windows system and where it starts from. Its path, its description, where its registry key is, which is generally where these things are stored. So here's all the registry keys, and here's all these services, HKLM, System Current Control Set Services. Here's all this stuff, okay? So you can see where everything that starts on a Windows system goes. This is the Everything tab. If you want to look at stuff just at login, you can see that. If you want to look at stuff that runs under WMI, just like that, Office, I don't have Office installed in this system, you can see everything separated that way. So very, very cool stuff. One of the key things about this particular tool is that it also gives you the option to do two things. Number one, hide the Microsoft entries, which is really nice because we know the Microsoft stuff on this system is legitimate. We're looking for this WinHost. And secondly, the other thing it allows us to do is to go into scan options and check virustotal.com. And it will actually rescan the image and submit the hash to VirusTotal and give us the exact same thing. Very, very, very cool stuff. So once the hash is submitted and it does this thing, it takes a little while to rescan, but we'll see here some of them are already done. For the most part, we're going to see stuff that either the file's not found in this particular case, there's a startup location here, but that particular piece of software has been removed and it didn't properly clean it out, or we can see software that's running, and again, it's submitting hashes and it's taking a little bit longer than thought. But here's the interesting one that we're looking for is this WinHost piece of software right here. And we will see that, again, VirusTotal will not find the hash. We know this is the process we need to get rid of. It starts under HKLM software, Microsoft Windows Current Version Run. How do we get rid of that automatic entry so that it doesn't start again? We uncheck this box. Okay. Now Mark's going to show you an example of why you don't want to just delete this. Because if it's set up, a lot of software will set it up itself to replace Explorer.exe and run as your shell. If you delete that entry, you no longer have a shell entry in the registry and your system's dead as a doornail. So it's not something where you want to automatically delete in that particular instance. But before we do this with WinHost, the first thing we want to do is kill the process, because the process is running right here. We can do a couple of different things by right-clicking. We can kill the process. We can kill the process tree. We can restart the process if you want to do that for some troubleshooting purpose. We can submit it to VirusTotal, look at its properties. One of the things that's highly recommended with regards to process killing is this. A lot of times malware will actually spawn 2 copies of itself, and if you kill one, this one here will start another one, and then when you kill this one here will start another one, and you can do that all day, and it's just basically a way of it defending itself. So the way to get around that, and a better best practice to get used to in terms of malware, is actually to suspend the process first. Suspend it in RAM and then kill it. So then after we've done that, we're going to kill this process. We know that it's winhost.exe in the Windows directory, so we're going to kill the process. And it's going to ask, do you want to kill it? Yes. Process goes away. Then we go over here to auto runs. We uncheck that box. Okay. Now the process won't start. Now we go in the file system, delete the file, and that particular process has basically been removed from the system. So those are the basic tools. Again, you're going to see some good examples from Mark in a few minutes here. So again, we talked about Process Explorer High Internet. These are some tips that you can use. It shows the colors, where to find properties, and how to use the tooltips, that sort of a thing. Showing you auto runs. Last one I want to show you is Process Monitor. Process Monitor is very cool for a couple of different reasons, but it's very, very useful when it comes to dealing with software. Process Monitor is again part of the same toolkit, and I'm going to run it as high integrity. This particular piece of software will blow your mind if you look at it too long, because it will record everything that's going on a Windows system. Everything. Everything a process is doing, whether it's writing or reading stuff from the registry, the file system, talking on the network, show a lot of information. But say, for example, you want to see what a particular process is doing, you can do some very, very good filtering in Process Explorer by basically using this thing called the process tree, which allows you to look through the processes here. And you can say, oh, okay, I just want to look at what command.exe is doing here. So we can include it and its subtree and only see what's going on there. That's really nice for isolating. So if you wanted to see what winhost.exe was doing before we killed it, that's the way to do it, is open up and Process Explorer and see. Now the other thing we want to do, one of the best things to do in this particular tool, is to go over here and change the category, or add the category to write. And then click add, and it will add it to the filter. So basically now we're going to be able to see everything that this process is doing when it writes something to disk. So if I go back to the command prompt here and I go to root and I echo hello towards temp.txt, and I come back, it actually shows me command.exe created the file temp.txt and wrote to it. You can use this for troubleshooting software, for troubleshooting applications, for troubleshooting a lot of things, but it's also very cool looking at exactly what the behavior of a particular piece of software is going on. And Mark's going to show you an example of that in a second. And I showed you TCP view. This takes practice. You want to watch your Windows systems, learn what's normal in your environment. Go to live.sysinternals.com, play with your system, open it up, see what's running on your system. Be very curious, because it's that curiosity that finds stuff. And just basically practice doing this stuff. Practice looking at what's normal in your environment. So when you walk up to one of your systems, you could launch Process Explorer, and pretty much quickly, you'll be able to pretty quickly see what might not be normal in your environment. And again, you want to safely use your tools like we talked about. If you're using a USB key, format the USB key after you're done, restore it from live.sysinternals, or just run the program directly from live.sysinternals. If you have access to a Linux system, there's DD, which is a very, very handy piece of software for restoring your image of the files that you have. So for those of you who are watching at home, we're not going to show Mark's demos in this particular video, but you can go to this YouTube link and watch the malware hunting presentation, which is fantastic. If you just want to watch the demos that we are showing, the demos start at 4153. Thanks for being with us.